All right, class, welcome to part 3. We're going to go over questions 21 through 30 in this area. So let's just go ahead and get going on this. So we're going to start with question 21. So 10 years after purchasing a mutual share of 7,500, you sell them for 12,600. Compare the annual return of the investment round to nearest percent. So the trick here is the annual return. So you have to remember that that's what we're looking for. So our annual return equation, and you can go look for this one, it's A divided by P, or the future value divided by the principal, raised to the power of 1 divided by the number of years. And then when we're done with that, we subtract out that principal value again, which will give us that percentage. So let's go ahead and put in the values we know. We do know that we have 12,600. We do know our principal is 7,500. And we know that the number of years are 10 years. So 1 divided by 10. And we'll subtract 1. So now we go to the calculator, 2,600. Now if you remember, 1 divided by 10 is actually 0.1, so keep that in mind. So 12,600 divided by 7,500. And if you didn't know that, you could always go 1 divided by 10 to figure that out before you get to the stage, but then I raise it to the power of 0.1. And then I subtract 1. And so 5.3% roughly. And they said round to nearest percent, so 5% would be it. And there we go, C is 5%. So that's our annual return of the investment. So how much we make, about 5% per year. And that's on average over the 10 years. All right, let's look at number 22. When you pay $8,000 for a mutual bond, it matures after 20 years and you receive $12,500. You want to compute the total return of this investment. Okay, so we're looking for the total return. That's how much we've earned over all 20 years combined. Okay, so from when it started to when it didn't. And then this one is actually pretty easy. We just have to remember that the total return will be equal to the future value minus the principal divided by the principal. So in this case, 12,500 minus our initial 8,000 principal, and we'll divide that by 8,000. So this is actually pretty quick to compute. We'll subtract the 8,000 and then divide it by the 8,000. And we have about 56.3%, so it says round to nearest percent, so about 56% is how much we made over the 20 years. So it's not a year average. And there we go, A is 56%. That's the answer. All right, number 23. At age 25, you set up an IRA with an APR of 5%. Each month you deposit $75 into the account. How much money will you have in the IRA when you retire at 65? Okay, so since we have a monthly deposit, this is going to be a little bit trickier, and you're going to have to remember that formula. Okay, so we're looking for the amount, and this is where I would go, since we have a monthly payment that we have to do, I would go look up this formula, unless you have it memorized. But we have the payment that we put in, okay, and then we're going to multiply it by the principal, 1 plus the rate divided by the number of compounds, raised to the power of number of compounds per year. So my t is just representing the year, and we're going to subtract 1. That whole thing will then be divided by the rate divided by the number of compounds. So this calculation right here, this formula, will actually give me the amount I have if I put $75 payments in over that period of time. So since we're not starting with a principal amount, I don't have to worry about that in this equation. So we're doing $75 and 1 plus the rate of 5% divided by 12 compounds, because we're doing monthly payments. 12 times the number of years. 65 is when I retire, 25 is when I start. So 65 minus 25 is 40. So that's how I get this 40 up here. Then subtract 1, and I'll do that all over 0.05 divided by 12. So I'm going to do the bottom area first. So 0.05 divided by 12 will give me 0.00416666. So I'm going to store that in memory, but I could go 417. And that would probably be a rough estimate. But I'm just going to store this in the memory. Make sure I have it in the memory. Okay, good. All right, so now we're going to go up and finish the top, divide by that number, and then multiply by 75. So we're going to go 0.05 divided by 12. Actually, I should have just kept that up there. There we go. Add a 1. okay? And so now we're going to take that value and raise it to the power of 12 times 40. Well, 4 times 12 is 48, so this is 480. So I'm going to click on that value and go 480. And so that value right there is equal to 7.358. I'm going to subtract 1, or 6.358. Divide that by the value I just have on the memory. So divide by the memory recall. And so that'll give me 1526. And we're going to take that whole value times the 75 for a total of 114,451, or 114,451. That's the amount of our investment over 40 years. So let's see which one. There we go. Number D is the correct answer. That's how much money the IRA will contain after 40 years if I just put $75 in for 40 years every month. All right, let's move on to the next question. 24. So we'll go over here. Go up to 24. All right. So what we're going to do is how much of the ending balance in this problem above comes from interest and not from your own monthly contributions, okay? So that problem above, 23, is what we're using, okay? So remember, we had, there's the value, 114, oops, there we go, 114, oops, I went black. Oh well, that's fine. I think so. Read that 114, 451.51. So that's how much. It's very sloppy. I apologize for that. But that's how much we have. Now we want to figure out how much of that was our payments. And so we are going to recalculate this. Our payments. Go back to the blue. Okay. So our payments, remember, were $75 times 12 months times 40 years. Okay, so 75 times 12 months. That's how much we paid per year. And we did that for 40 years to get $36,000. So $36,000 is how much of that I put in. The rest of that was interest. So 114, 451.51 minus that $36,000. This is how much, okay, is interest that I was not my monthly contributions. So we'll find 78,452 is the correct answer. All right, moving on to the next problem, number 25. Assume a person saves diligently for a long-term savings plan for 30 years and then retires with $1 million in his or her retirement account. Good for them. How much purchasing power would that amount have in today's dollars if the annual inflation rate averaged about 2.5% over that same 30 years? Okay, so since we're going to be doing this, first off, what we want to do with our calculation is our compounded annually, okay? For interest is, you got to remember that. So we have A is equal to our principal 1 plus R raised to T. Okay, so that's, once again, you could do APR. Your formulas on your sheet will have APR here and a Y here, but this is the exact same thing. So one thing we have is we're looking for purchasing power and inflation rates. So one thing is we know we want $1 million. And this is where you have to think about this backwards. $1 million. And that's equal to P times, now the rate we have is, inflation rate is about 2.5%. And this is 30 years. Okay? So that's how that formula would look. You can actually divide both sides by that value of 1. So we have $1 million divided by the 1 plus 0.025 raised to the power of 30 is equal to the principal. So we'll come over to our calculator. 1.025 raised to the power of 30 years. There's the value. I'm just going to clear out the memory and store that in memory. Make sure I have that in memory. Good. So we'll do $1 million. I hope I have enough zeros there. Okay, good. And we'll divide that by our memory recall. And that value is how much our principal should be so that way as it decreases over 30 years. And remember, you got to think of inflation kind of working in the opposite direction. So 476, there we go, number D, letter D, is the correct answer. That matches my answer. Okay, so that's 25. Number 26. What if you wanted to become a millionaire and had 45 years to get that goal? Assuming you could earn interest at a rate of 7% compounded monthly, and you started with nothing whatsoever in your investment, how much would you have to contribute to your annuity each month to receive your goal? So what we're looking for now is that payment. We don't know the payment, but we want the payment. So we have to go back to that formula of A is equal to the payment times 1 plus the rate divided by the compounding, and T minus 1 divided by R over N. So what we want to do is we're looking for the payment. So we can actually rewrite this equation if I multiply by this by the reciprocal, which is R over N, and that whole value. I could retype it out, but I'm just going to say that cancels out with that cancels out with that, and I'm left with the payment. So A times R over N over 1 plus R over N raised to NT minus 1 is equal to my payment. And so there's a formula that will help me calculate my payment. So I run out of room here, so I'm just going to go to the next page and rewrite all of this with the values in it. Okay, so this is 26 continuing. I'm just going to fill out that value. So it was the amount we want. Now remember, our future value we want is $1 million. We're not starting with any principal, so we're going to multiply this $1 million by that rate, which in this case is 7%, divided by the number of compounds, in this case is 12. And we'll divide this by 1 plus the rate, which is 0.07 divided by 12, raised to the compounding times the number of years. In this case, we have 45 years to achieve this goal. So we'll put a 45 there, and then we subtract a 1 when we're done with that. And there we go. So I want to do the bottom first, because then I can store that in memory, take the top, divide by the bottom. Okay? So I'm going to make sure my memory is cleared. We're going to do 12 times 45. I'm just going to do that to verify what that will be. So that's 540, so I'll remember that, 540 up there. So 0.07 divided by 12 gives us this value. We add a 1 to it. Then we raise it to the power of the 540 that we had already calculated previously, and minus a 1. And so that's 22.1234, and we'll store that in our memory, make sure that that recalls properly. Then we come up to the top and do 0.07 divided by 12. To get that value, we'll divide that by our memory recall. Oops, let's try that again. 0.07 divided by 12. And we'll divide that by the memory recall. And there is the value that we're going to multiply $1 million by. 123, 123. $263 should be my payment and 67 cents. So about roughly $264 if you round to the nearest dollar. And there we are. So D is our correct answer. And we'll move on to 27. All right. So assuming that a 5.25 rate of return compounded quarterly would have an accumulated balance in the savings plan, has an initial deposit of $100,000 and quarterly payments of $500 for 40 years, round to the nearest dollar. Okay, so this one does have, we have an initial deposit, okay, that we have to consider, and then we also have payments. Okay, so let's come over here and let's do first the value of the initial deposit, which is the principal times 1 plus R over N, NT, which is $1,000 times 1 plus the rate, which in this case the rate is 5.25, and we're compounding quarterly, so we do a 4, and the number of years is 40 years. Repeat my 4. There we go. So what we're going to do now is, this is the initial value, we'll calculate that, then we'll have to calculate the payments and then add the two together. So that's what we have to do with this when we use this equation. So let's start with 0.0525, divide that by 4, add a 1. So there's our value in here. We're going to raise that to the power of 80. There's our value, multiply that by $1,000. And we get, let's see, did I do that right? Let me try that again. 0.0525 plus 1. I'm sorry, divided by that. 0.0525, divide that by 4. And then add 1 to this. And then raise that to the power of 80. And multiply that value by 1,000. Oh, I see what I'm doing wrong. 4 times 40. Ugh. Okay. So I was expecting, it shouldn't be, the reason why is because after 40 years, it's going to be closer to over $5,000 easily. And so I'm getting below that. So that's why I'm kind of like saying I'm doing something wrong here. So 4 times 40 actually happens to be 160. So that's where I was messing up on that calculation. So let's try this again. 525 divided by 4, add 1, and now we'll raise it to the value of 160. So I wasn't getting the answer I wanted because I wasn't going as many years. And we'll multiply that by 1,000, and that actually looks a little bit more realistic. So remember that if you're doing $1,000 over 40 years at like 5% interest, you're going to have a lot more than double. Because think about the half-life. As doubling life. So that's how much we have for our amount, $8,055.36. Now we need to also calculate how much with our payments and then add those two together. So we're also looking for the amount of the payments times that 1 plus R over NT minus 1 all over R divided by N value. So remember, our payments in this case are $500 we're going to make per month. Well, I'm sorry, quarterly payments of $500, because remember, we're compounding quarterly, so we put 500 quarterly payments in. So $500 times 1 plus R divided by 4. The rate in this case happens to be 5.205, so 0.0525 divided by 4. Raise a value of 4 times, and we're going to be doing this for 40 years, minus 1. All divided by R divided by N, which is 0.0525 divided by 4. So I'm going to do the bottom first and store that in memory. So 0.0525 divided by 4. We'll store this into the memory. So memory. And actually notice that that's going to be the same value here, so I'm going to add a 1 to it. And then raise that to the power of 160. So there's that same value. Notice that actually happens to be the same as this one was right here. We'll subtract 1 from it. And then we'll divide by our memory recall. And we'll multiply this by $500. So $268,775.76 will be from the payments of putting $500 each every 3 months or quarterly. We're going to add to that the initial amount we put in, which is $8,055.36. So over this time period of the two, we have $276,831.12. So D is the correct answer. Okay, 28. How much of your ending balance of the problem above comes from interest and not from your contributions? Okay, so we have how much was done with the interest. So we're going to have to calculate our interest, our payments, and then subtract it from that. Okay, so let's do this. We know that we had $1,000 that we put in right off the bat, and we know that we had $500 that we did 4 times a year, and we did that for how many years? Let's see, 4 times a year for 40 years. So we go 500 times 4 times a year times 40 years. Add on to that the $1,000 that we started with. So $81,000 of that was what we put in. And so we want to find out how much is interest, so we take the top number minus the 81,000. So we'll take 276,831.12 minus $81,000. We get 195,831. So that's the interest. I wonder if they did that on purpose, but if you see that that's bold, that's because it's the correct answer. Woohoo! They forgot to unbold that, so you could have guessed. Don't think you can use that strategy on the test, but you never know. All right, 29. What type of fallacy is shown by the following argument? Each of my brother's 3 dogs has fleas. Therefore, all dogs has fleas. Well, you'll notice that we have in here our, we have one example, a very specific example that each dog has 3 fleas, that has 3 of his dogs have fleas, therefore all dogs must have those fleas, and that's just a generalization. So hasty generalization is the answer on that one. It's not circular reasoning, straw man, or false cause. So you can say nope, nope, nope. It's a hasty generalization. Because you take one specific example and say, oh, it must be for all cases. And number 30, what type of fallacy is shown with this argument? You should brush your teeth every day because brushing your teeth is very important. Well, look at the options. False cause, that's not the case. I'm thinking circular reasoning, and the reason why is because you should brush your teeth every day because brushing your teeth is important. And why is it important? Because you should brush your teeth every day. And so it's you can see how that's just kind of like going in a circle and a circle. Okay. You should brush your teeth because brushing teeth is important. Therefore, why is it important? Because you should brush it every day. So we're just going to create that argument over and over. Okay, so we'll do questions 31 and then through 40 in the next part.